Hey everyone, if you're gearing up for the CUET chemistry exam, you know that every single mark is like gold. Today, we are going to tackle one of the absolute highest scoring chapters, solutions. And I'm telling you, stick with me for just the next few minutes and you'll be grabbing some totally free marks.
Okay, let's just jump right in. Look at this question on your screen. If this popped up on your exam right now, could you nail it in like 10 seconds? A lot of students, and I mean a lot, they panic right here and they lose a super easy mark, but not you. Not after this.
Because here's the game plan. We're going to hit all the essential memory tricks. We're going to uncover the common exam traps that the examiners just love to set, and we're going to eliminate those simple mistakes that cost you marks. We're talking colligative properties, Henry's law, Raoult's law, the whole shebang. So whatever you do not skip ahead. This could seriously be the difference maker on your exam. You ready? Let's go.
First up, let's get you armed with some shortcuts. Seriously, think of these as your secret weapons. They're going to save you precious seconds in that exam hall and help you lock in the right answers with total confidence.
So this one is absolutely crucial. The difference between molarity and molality. Okay, molarity has volume in it. And what happens to volume when you heat it up? Right, it expands. So that means molarity changes with temperature. But molality? That's based on mass, and mass doesn't care if it's hot or cold. It stays the same. Trust me, this is a favorite question for CUET examiners. They love to ask this.
So how do you remember that molality is the one with mass? Simple. Here's a little trick. Just remember this. Mola equals mass. See that? The law in molality links right to the ma in mass of the solvent. It's a foolproof way to never ever mix them up again. This is very important. You should probably write this one down.
All right, let's talk about ppm, or parts per million. I know this one can look kind of intimidating, but it's actually super simple. Just think of it like this. 1 tiny milligram of something dissolved in a whole liter of solution. The only shortcut you need? Just remember, ppm equals milligrams per liter. You'll see this all the time in questions about pollution and stuff like that.
Now this is a perfect way to picture Raoult's law. So what happens when you add a non-volatile solute, like salt, to water? Just imagine the little solute particles are like tiny security guards standing on the surface, and they're blocking the water molecules from escaping into vapor. The more solute you add, the more guards you have, and the lower the vapor pressure gets. It's really that simple.
Okay, building on that idea, let's talk about the 4 colligative properties. Now this is a source of guaranteed free marks if you can just list them. The only thing you need to remember is the word redo, R-E-D-O. Relative lowering of vapor pressure, elevation of boiling point, depression of freezing point, and osmotic pressure. Just memorize redo, and you've got this question in the bag.
Azeotropes. They seem to confuse so many students, but they really don't have to. Here's the only trick you need to know. When a solution shows a positive deviation from Raoult's law, it forms a minimum boiling azeotrope. The shortcut couldn't be simpler. P leads to M. Positive deviation equals minimum boiling. That's a direct MCQ just waiting for you.
And finally, for our shortcuts, let's decode the Van Hoff factor, I. Look, all it does is count the actual number of particles you have floating around in the solution. If particles associate, or, stick together, you have fewer particles than you started with, right? So I is less than 1. If they dissociate, or split apart, like NaCl does into Na plus and Cl minus, you have more particles, so I is greater than 1. Examiners absolutely love testing this in numerical problems.
All right, now that you've got the shortcuts, it's time to play some defense. We need to anticipate the traps that CUET examiners set for students who aren't paying attention. These are designed to look easy, but they will catch you off guard if you're not careful.
The first trap we actually already covered. Molarity changes with temperature, molality does not. Don't let them trick you. Next, they'll get you by assuming solutions are ideal. You gotta remember, most real-world examples, like that classic ethanol and water mix, are non-ideal. And the third big one is misinterpreting Henry's law. It's simple. Higher pressure equals more gas dissolves. Just think of a soda bottle. It's fizzy because it's bottled under super high pressure.
2 more huge traps right here. First, colligative properties. Students often think it depends on what the solute is. Is it salt? Is it sugar? Wrong. It only depends on the number of solute particles. That is the whole game. Second, the osmotic pressure formula. People mix it up with the ideal gas law all the time. It's pi equals mRT, not nRT, mRT. Write it down, burn it into your brain. Okay, here it is, a classic trap question. Take a look.
Can azeotropes be separated by simple distillation? The answer seems obvious, but it's totally designed to catch you. What do you think?
And the answer is a hard no. In fact, that's the entire point of an azeotrope. It's a mixture that boils at a constant temperature, which means the vapor has the exact same composition as the liquid. You simply cannot separate its parts by simple distillation. This is a fundamental idea they just love to test.
All right, let's move on to our final section, critical student mistakes. Now, these aren't really traps set by the examiner. These are just unforced errors that cost students guaranteed marks. Let's make sure you don't make them.
First, units. Always, always, always check your units. A simple mix-up between ppm, molarity, and molality can completely wreck a problem you solved perfectly. Second, don't mix up association and dissociation. Just remember, association means fewer particles, so I is less than 1. Dissociation means more particles, so I is greater than 1. And third, this is a tiny but critical detail. Molality uses the mass of the solvent in the denominator, not the whole solution. That one little word can change everything.
And here are the final errors to watch out for. Forgetting that ideal solutions have zero heat change on mixing. Getting confused on colligative properties. Remember, NaCl breaks into 2 particles while glucose stays as 1, so NaCl is going to have a way bigger effect. And finally, misremembering the core definition of an azeotrope. What is it? It has a constant boiling point. Period.
Okay, wow, we've covered a lot of ground. Let's do a super quick, rapid-fire, high-yield recap of the most important points. Get ready to screenshot the next slide. This is your ultimate cheat sheet for that last-minute revision.
Here it is. 1. Molality is independent of temperature. 2. Colligative properties are redo. 3. Positive deviation means minimum boiling, P to M. 4. Henry's law, solubility is proportional to pressure. And 5. Van 't Hoff factor, association is less than 1, dissociation is greater than 1. Seriously, pause and screenshot this right now. These 5 points can easily win you multiple questions on exam day.
So there you have it, a complete breakdown of the key concepts, the tricks, and the traps for the solutions chapter. If this explainer helped you, please make sure you save it for your final revision, because trust me, you will see a question from this chapter on your CUET paper. Let me know down in the comments which trick was your big aha moment. Good luck and go ace that exam.